Hello, this is the video on mole conversions. So hopefully by now you've looked over the PowerPoint and you've taken down some of the notes, and it probably still doesn't make very much sense to you, so that's what I'm trying to clear up with this video. So this is how this goes. A mole is like a dozen. So if you have a dozen of anything, it's 12. If you have a mole of something in chemistry, it's 6.022 times 10 to the 23rd of those things. So if you had a mole of school buses, it would be 6.022 times 10 to the 23rd school buses. But that doesn't make sense in chemistry. What we measure, and we have in the past, is atoms and molecules. So if you have 1 mole of copper, you would have 6.022 times 10 to the 23rd atoms of copper. If you had 1 mole of water, water is H2O, that's a molecule. So you would have 6.022 times 10 to the 23rd molecules of water. And that's how moles work. And we use moles to connect things because we don't have a mole meter. We don't have something in the lab that can measure moles, but we do have something that can measure mass. And we have things that can measure volume. So the mole kind of ties all these things together. It ties together how many particles there are, what the mass of the substance is, and if it's a gas at standard temperature and pressure, it'll tell you the volume. So I'm going to do some problems, and then you'll do some problems that are similar, but it's just like what we did with the metric conversions. And I told you there would come a time where things wouldn't be based on powers of 10, but the method would be the same. And that's what this is. The method is going to be the same. You're going to take whatever is given and put it over 1. And then you're going to choose 2 parts of this big equation, which you never have to memorize. You're going to pick 2 parts and you're going to make a conversion factor, just like you did with the metric conversions. So I'm going to do 5 with you, and then hopefully that will be enough and you'll be able to do some on your own. So the first one says that we have 2.5 moles of calcium, and we want to know how many grams of calcium this is. This could also be worded like as a sentence or a question, and it would say, if you have 2.5 moles of calcium, what is the mass of the calcium? Mass and grams goes together. Mass is the quantity and grams is what you measure it in. So what you would do is you would take whatever's given and you would stick it over 1. You would stick it over 1. And then you have to figure out which conversion you're going to do. So you're trying to get grams. So just like when we did the metric conversions, you're going to do the same thing. You're going to put whatever you're looking for in the numerator of your conversion, and whatever you're trying to get rid of is going to go in the denominator. So I'm trying to find grams, so that's going to go in the numerator. In the denominator, I'm going to put moles because that's what I'm trying to get rid of. And then I look at my big equation. In front of the mole, every time is a 1. And now, in the top part, this is a little trickier than what we did with the metric conversions. To get grams, grams is formula mass. Well, this isn't a formula, it's just an atom, but we have a periodic chart and we look it up. So calcium is 40.08 grams. So 1 mole of calcium has a mass of 40.08. I get that from the periodic chart. Then I just do math. The moles are going to cancel out, and I'm going to take 2.5 and multiply by 40.08, and I'm basically going to get 100 grams. And that's all there is to it. Every single one is done the same way. So the next one, you have 450 grams. So this time I'm giving grams. I've taken my balance and I measured out 450 grams of calcium oxide. And I want to know how many moles are in that. What is the equivalency? And remember, when you're doing this, you're not changing how much you have, just like we did with the metric conversions. This is just changing like from quarters to dollar bills. It's the same thing. So we're going to start out with 450 grams. And we stick that over 1. And that doesn't change how much you have. And then you set up a conversion factor. I want to find moles, so that goes in the top part. I want to get rid of grams, so that goes in the bottom part. And then just like I did before, I look at my big equation. In front of moles, I always put a 1. In front of the grams, I'm using this part of the equation right here. This is where I'm going to use my periodic chart. But this time, instead of it just being 1 element, it's a whole compound. So I take the calcium, which is still 40.08, and I add 16, because that's what the oxygen is. And I get 56.08. And the grams will cancel out. And this time I divide 450 divided by 56.08, and I get 8.0. And that's how many moles of calcium oxide I would have. Every single one is done the same way. Moving on to the next one. This one I have 17 moles of nitrogen dioxide, and I want to know how many molecules that is. Well, that's a different part of the equation. So I'm still going to be using the mole part, but this time I'm going to have to use this large number. That's what a mole stands for. So I still do the same way though. I take 17 moles of nitrogen dioxide and I stick that over 1. I'm trying to find molecules, so that goes in the top part. Don't abbreviate this, because if you abbreviate this, you tend to get it confused with moles. It's molecules. In the bottom part is where you're going to put the moles. That's what you're trying to get rid of. Then you look back at your big equation. A 1 goes in front of the mole, and in front of the molecules, 6.022 times 10 to the 23rd. This is why we spent so much time on scientific notation. So then I take my calculator and I take 17 and I multiply by 6.022. Remember how to use your EE function on your calculator, or your EXP, or whatever yours has. And I'm going to get 1.02 times 10 to the 25th molecules. And that's my answer. The next one, a little bit different. This one, I know how many atoms of copper I have, and I'm trying to figure out what the mass of the copper is, because mass is grams. So once again, I take whatever is given, and I stick it over 1, and I make a conversion factor. So I'm trying to find grams, so that goes in my numerator. I'm trying to get rid of atoms, so that goes in my denominator. And then because of math, these will cancel out, because anything divided by itself is 1. In front of the grams, I have to find the mass of the copper. Once again, when I'm doing the conversion factor with grams, I have to find my periodic chart, look up copper, 63.55. In front of the atoms, look at my big equation. I find the mass, that's what goes in front of grams. The atoms, I put 6.022 times 10 to the 23rd. Always show this much work, because it's very easy to make a math mistake or a calculator mistake at this point. So I'm going to take the 3.6 times 10 to the 24th, and I'm going to multiply it by 63.55, and then I'm going to divide it by 6.022 times 10 to the 23rd, and I'm going to get 380. So that many atoms, a lot of atoms, is equal to 380 grams of copper. It'll be different for every different element, but for copper, if you had that many atoms of copper, that's what its mass would be on the electronic balance. The last one deals with gases, and the only time you can use the last part of the equation, this part here, is if it's a gas at STP, which stands for a standard temperature and pressure. So I take 15 grams, that's what's been given, of helium, and I put it over 1. And I need to change from grams of helium to decimeters cubed, which is a volume. So I set up a conversion factor, I put decimeters cubed in the top, and I put grams in the bottom. I look at my big equation. Everything goes back to the big equation. In front of decimeters cubed goes 22.4. In front of grams, I've got to get that from the periodic chart. So on my periodic chart, helium says that the mass is 4. The grams will cancel out. I take 15 times 22.4 and divide it by 4, and I get 84. 84 decimeters cubed. And a decimeter cubed is a liter. So 84 liters. That's how much space it would take up. That's pretty much it. Every problem is done exactly the same way. You just have to know, for the big equation, when you're doing the conversion factor, a 1 always goes in front of the moles. 6.022 times 10 to the 23rd always goes in front of molecules or atoms. In front of the grams, you have to look this up on the periodic chart. And if it's a gas and it's decimeters cubed, you're always going to put 22.4. Hope that helps.